Number 1. Which fraction equals a repeating decimal with a 3-digit repeating block? The correct answer was B. It actually came up to 0.063 repeating. If you take 7 and divide it by 111 on your calculator. Number 2. The area of the top of a small square table. They're talking about the area of a square table. I'm going to write down the formula for a square. Area equals side squared. They said the area is 0.25 square meters. So I'm going to replace A with 0.25. And what is the opposite of squaring something? Square rooting it. So S is equal to the square root of 0.25, which is 0.5, which is why D is the correct answer. Okay, take 0.05 times 0.05 on your calculator. Take 0.5 times 0.5 on your calculator. Because you count decimal places, correct? Any questions on 1 or 2? Number 3, which is the best estimate of 0.65, and you're taking the square root of it. If you punch that into the calculator, there's your first 3 digits, 0.806. Now, I saw a lot of people make this mistake. They saw 86, they wrote this one. This 6 is going to round this 0 up to a what? A 1. So 0.81 would be the best estimate of the numbers that are there, which would be C. Number 4, what is always true about a positive integer raised to a negative odd power? Listen, if they're talking about a positive integer, I would stay away from 1. 1 is kind of a unique number because 1, if I put to a negative exponent, would just be 1 anyway. So it's kind of unique. I recommend, since they want it to be generic, if I wanted to look at something, that I'd pick a small integer. So I might use 2, I might use 3, but I'd stay away from the larger ones. Likewise, when it said a negative odd power, I would stay with the smaller number so I didn't have to multiply out so many times. I might use a negative 1, I might use a negative 3. What's the rule with a negative exponent? That's with scientific notation. Right. You're going to put it in the denominator in order to change its sign to a positive. We don't leave negative exponents unless we're talking about scientific notation. This is the same as 1 over 8. So, I started out with a positive integer. I ended up with a positive number. No longer an integer, though, is it? A is the correct answer. It will not ever be negative. The only time it would be divisible by 3 is if I started out with something that was what? Divisible by 3. Is it ever going to be greater than the integer I started with? No. No way for it to be greater. It could be equal. When would it be equal? If the integer I picked was what? 1. Because 1 to a negative power is still going to be what? 1. So that's why A is the correct answer for number 4. Are there questions on 3 or 4? Number 5, what is always true when 2 whole numbers are subtracted? And again, I would try to stay with small numbers. And I would always recommend that you pick something to do. I might do 5 minus 3, which would give me 2. But it's also possible that I could have done 3 minus 5, which would be what? Negative 2. So, what is always true about two whole numbers that are subtracted? Are they ever going to be irrational? No. Is it going to be an integer? Yes, that is the correct answer. Would it necessarily be a whole number? No, it could have been positive, but it could be negative, depending on which way I subtracted them. And the answer is not real. We're not dealt with imaginary numbers yet. Okay. What is the acronym for adjusting scientific notation, and what does each letter represent? Marcus? It's LARS, which stands for left, add, right, subtract. In scientific notation, if I move the decimal to the left, I have to add. Or if I added to the exponent, I have to move the decimal to the left. If I move the decimal to the right, I have to subtract from the exponents. If I subtracted from the exponents, I've got to move the decimal to the right. Number 7. When you're working this one out, this is just a calculator problem. If you punch in the square root of 14 plus 6.2, the square root of 14 plus 6.2 is approximately 9.94. And it's saying compared to 3 times pi minus 8.2, which would be approximately 1.22. Is that true or false? That's false. 9.94 is definitely not larger than 1.22. So number 1 is false. And when I go to do the next one, 17 fifths. By the way, what's the square root of 64? 8. This comes up to about 11.4. Likewise, this is going to be 8 plus 3.14, which says 11.14. Is 11.4 bigger than 11.14? Yes. This is true. 11.4 is like $11.40 compared to $11.14, right? This is definitely a true statement. 35 minus the square root of 40 is approximately 28.68. And it says it's going to be greater than 6 times pi, which is going to be approximately 18.84. Is that true? Yes. Which of the following then are false? The only one that was false was number 1, which is why A is the correct answer for number 7. Again, number 8 is kind of a calculator problem. We're going to take 7 times pi, 3.14, divided by 6. This is a negative 3.66. And the square root, the negative square root of 30 is negative 5.48, or approximately 5.48. And it says which number is not between here? Well, negative 5 is certainly in between. Negative 4 is also in between. Negative 4.5 is in between. But negative 3.5 is between 0 and the negative 3.6. Are there questions on 7 or 8? Number 9, a website gives the population of a European country as 16,714,683. What is this population? Well, I see they're putting it in scientific notation. I had to move 3, 6, a total of 7 places, 1.67 times 10 to the 7th power. The correct answer is A. For number 10, when you're multiplying scientific notation, you can multiply the numbers that are in front of your powers of 10, 6.4 times 3.2, and you can multiply the powers of 10, 10 to the 9th times 10 to the 3rd, by using the quotient rule. And I know a lot of people that applied the quotient rule and they stopped right there and marked this as an answer. But be careful. When you multiply 6.4 times 3.2, you get 20.48. The reason this isn't in scientific notation is the number in front of the decimal is greater than 9. I'd have to move it one place to the left. If I move it to the left, I have to add 2.048 times 10 to the 13th power, which is why B is the correct answer. Questions for 9 or 10? Number 11 realistically goes to the question that everybody keeps missing on the mastery test. As many times as I've gone over this problem, telling you that there's a difference between this and this. Exponents come before subtraction, and that's how it treats this. This is taking the 1 and squaring it, which would leave a negative 1. This, because it's in parentheses, saying I'm taking a negative 1 times a negative 1, which would make this a positive 1. This negative is in parentheses. It will produce a positive, a negative times a negative. A negative times a negative would produce a positive. No matter what this is, it's going to be a positive number. This is already a positive number. This one's saying I'm taking a negative times a negative times a negative times a negative. I've got a negative in there 4 times. This will also be positive. What's being raised to the 4th power here? No, what's being raised to the 4th power? The 6. And it's going to be negative when I get done. That's why this one is not equivalent. Okay? Goes right back to that mastery test that we've taken 4 or 5 times already. Be careful if that negative is not in parentheses. The exponent has nothing to do with the negative. Questions on number 11. Okay. Number 12 is simply something that you'd punch into your calculator. 53 divided by 16 is 3.3125. Number 13, I really don't need to look at this 8 that's out in front. All I really need to do is the 4 divided by 7. And I want you to see what that looks like on a non-scientific calculator. Four divided by 7. And if I'm looking at it going across 0.571428 5. When I I see this 5 again, what's the next number that's going to be there? 7. The next one? 1, 4, 2, 8, 5. And the question said, how many places repeated? Well, how many digits were there that repeated?
6.
There are 6. Now, not all scientific calculators are created equal. But if I do that on this scientific calculator, 4 divided by 7, it gives me a fraction. Okay? However, there's a button that I can push that will change that to a decimal for me. And notice what it does. It actually puts a line over those numbers that repeat. There are a lot of scientific calculators out there. Not many of them have that particular feature. As we get closer to the FSA, we will be getting a class set of the scientific calculators that you'll be allowed to use on the FSA to play with, so that we get a chance to learn what each one of these keys might do. Because there's a lot of keys on this that you may have not seen before, and a lot of them that you would not have to use at all. But on almost every scientific calculator I've ever seen, there's a fraction key, and they all look different. And so learning how to use that fraction key on a test could save you some time and effort. Okay? So, how many decimals repeated? 6. Number 14, where they asked me to simplify this. Remember, we don't leave negative exponents. To rewrite a negative exponent, we write it as a positive in the denominator. And 1 over 4 cubed is 1 over 64. On number 15, I would apply the product rule. I have like bases and I'm multiplying, so I would keep the base and I would add my exponents together, which would make this x to the 10th power.
Now, Mr. Huntley, for number 15, could you just keep it in the parentheses, or would you just have to add it?
Oh, you'd have to add it. If they're asking you to what? Simplify, you wouldn't want to leave 3 plus 7, because you can do that operation, correct?
Yeah.
Likewise, if they ask me to simplify, I really should take the 4 times 4 times 4, because I know how to do that. Okay, Brian? Oh, no. You'd leave it as 1 over what? 64. That's correct. And it becomes 4 to the positive third power when I flip it in the denominator, which is 1 over 4 times 4 times 4, which is 1 over 64. Okay? This applies this rule. It says if I have a base raised to a negative exponent, that I can rewrite it as a positive exponent by changing its location. If it was in the numerator, I write it in the denominator. If it was in the denominator, I write it in the numerator. Where is the only place we allow negative exponents? In what? Scientific notation. It's the only time it's considered acceptable. Anything else we need to change to positives. Brian?
Also about the can you use your own?
No. You can only use the ones that they provide us with, or the one that's built into the computer. That's because there's so many of them that do extra things that they don't want you to have. Number 16. The difference between 2 square roots of a whole number is about 5.3. Got to remember back to when we were talking about square roots, I said when you punch it into a calculator, it only gives you the primary square root, the positive square root. But when you're taking the square root of a number, it should give you a positive and a negative. So let's look at the square root of 4. It should be 2 and a negative 2. And the difference would be, you'd find by subtracting those two. So the difference between these two is half the distance to 0. Because half of it's on the positive side and half of it's on the negative side. So I'm going to take 5.3 and divide it by 2. 2.65. And they're saying what whole number that I take a square root of would give me this as an approximate value. Well, I know if I take the square root of 4, it gives me 2. If I take the square root of 9, it gives me 3. So I'm somewhere between 4 and 9. In fact, halfway between is 2.5, and it's above that, so I'm definitely on the top end. So I might look at the square root of 6, square root of 7, square root of 8. So go ahead, plug in the square root of 7 on your calculator, and you get 2.6457, whatever. So what they're looking for an answer then is what? 7. Number 17. Is a positive integer raised to a negative power always positive? Okay? And again, anytime they're talking about is it always positive, it's a good idea to think of an example, which they said I could explain with what? An example. I'm going to take a positive integer, 2. I'm going to raise it to a negative power, negative 2. That would be the same as 1 over 2 squared, which is the same as 1 over 4. Is it always positive? Yes. It's always going to be positive. My explanation is in the example. Mark?
I had one question about emergency real quick.
Okay.
Why did you divide it by 2?
Because when you're looking at a square root of a number, when we think about the square root of 4 or the square root of 9, right? It really produces two answers. It produces a positive 2, but it also produces what? Negative 2. And if I was looking at on a graph, 2 would be here, negative 2 would be here. So if the difference between these two numbers is 4, 2 minus a negative 2, then the distance that something is away from 0, either one of them is how far? 2 units. If I looked at the square root of 9, it would be 3 and a negative 3. The difference between these would be 6. But how far is 3 away from 0? 3. So I got to divide it by 2. That answer your question? They said that the difference between the two square roots, in other words, the difference between the positive and the negative. Well, let's take 2.645. It should be a positive and a negative. We'll take 2.645 minus a negative 2.645, which means I'm going to add 2.645. And it gives me 5.29. That's pretty close to 5.3, isn't it? So that's what they're asking. Number 18, explain why an integer cannot also be an irrational number. Integers can be written as fractions. If it can be written as a fraction, what is it called? No, if it can be written as a fraction, it's called what? It's called rational. And something can't be both rational and irrational. It's not possible. How do I write an integer as a fraction? Put it over what? Put it over 1. Notice number 19 says name the set or sets of numbers to which -7 belongs. It's real. It's rational. It's also an integer. But it's not what? It's not whole, and it's definitely not irrational. Or imaginary, which we haven't talked about really yet. Now, number 20, why is it not possible to plot the value of the expression on the number line, no matter what this works out to? This worked out to this. 0. Square root of 25 is 5. 5 minus 5 is 0. And what can't we do? We simply can't divide by what? 0. It's not possible. I can't take something and cram it into nothing. Questions on 18 through 20? Yep. It's not irrational, though. You simply can't do it. I can plot an irrational number on a number line. Approximate. I know what it's between, so I can roughly put it on a number line. I can't plot imaginary numbers, but I can't plot numbers that don't exist. And dividing by 0 just isn't possible. Number 21. You can divide the numbers in front of the powers of 10, and you can apply the quotient rule to the powers of 10 when you're dividing in scientific notation. 8.8 divided by 2.2 is 4. When you apply the quotient rule, this would be saying 10 to the 5 minus 3, and 5 minus 3 is 2. So this would be 4 times 10 to the second power. Okay, 22 through 24. Write the second largest number in standard notation. By the way, they were real nice. They organized them for me. They didn't have to. Do I want to look at the numbers that are in front of the decimal, or do I want to look at the exponents to compare sizes? I want to look at exponents. This one is the second largest exponent. 1.4 times 10 to the 9th power. So I've got to move my decimal 9 places. When I get 14, I've moved it once, which means I have to add 8 zeros. So you should have, what do we have? 1,400,000,000?
Let me make sure.
Number 23, how many decimal places are there in standard notation of the diameter of a red blood cell? So I have 8.4 times 10 to the negative 6. If I move it here, I've moved it one place already. I've got to add 5 lead zeros. So there is 1, 2, 3, 4, 5, 6, 7 decimal places. in this particular question. Number 24, about how many times larger? When you see how many times larger, what type of problem is it? It is a division problem. It says I'm going to take 1.54 times 10 to the 21st, the Milky Way galaxy, and I'm going to divide it by the nucleus of an atom, 7.2 times 10 to the negative 15th. I'm going to apply the quotient rule to the power of 10, giving me 10 to the 36th power. If I take 1.54 and divide it by 7.2, it gives me about 0.214. Is this in scientific notation? No. No. Here I would have to move the decimal one place to the right. If I move it to the right, I have to, right is subtract, 2.14 times 10 to the 35th power. Questions on 22 through 24. Number 25. It says describe the set of whole numbers. If you're describing a set, it should say that it is a what? It's a set of numbers. That's where I'm going to start. It's a set of numbers. Where does it start at? Starting at 0. 0 is in that set. And increasing by how much? Increasing by 1s. In other words, 0, 1, 2, 3. If they ask you to describe integers, how could you describe it?
A real number. A set of numbers on the number. So, numbers.
There's a simple definition. It's the set of whole numbers and all of its opposites. Okay? Because it includes 0, 1, 2, 3, but it also includes what? Negative 1, negative 2, negative 3. Okay? What if they asked you to describe a set of rational numbers? It's the set of numbers that can be represented as fractions, period. If you can represent it as a decimal, it can be represented also as a fraction. Okay? Other questions?